Hello, everyone, and thank you for attending. My name is Matt Radizak. I am a NX CAD application engineer with ProLim PLM. A little bit of background on me personally. So I have been with ProLim for about a year now. I was actually co-op here though for 5 semesters while I was still getting my bachelor's in mechanical engineering at the University of Cincinnati, and I recently graduated in 2020 with my bachelor's of mechanical engineering. So today we're going to be going through the NX Weld Assistant, and I'll be demonstrating some of the tools available inside of that application. In this webinar, I will be continuing from where Brian left off with his Structure Designer webinar, using his model to kind of show you what Weld Assistant can do. If you didn't get a chance to watch his webinar, that's not a problem. You can find it on our YouTube channel if you do feel like watching it at a later time. But this webinar doesn't hinge on you having watched that webinar already. This is a different topic entirely. It's just I'll be using his model as a starting point for this webinar. And after today's webinar, if you would like to go back and watch it again, we will be placing the same recording for this webinar on the YouTube channel where Brian's webinar is also located. Now, for a general agenda, I'll be going over some of the capabilities in Weld Assistant, including the solid welding. That's going to be the main focus, so your groove, fillet weld, stuff like that. I'll be talking about the PMI that you can create that's associated with those welds. So I can turn on PMI for each specific weld and have that PMI automatically brought into my drafting views, depending on my settings. So I don't have to create the welds the weld symbols when I bring it over into drafting environment. It's automatically created for me using that PMI. And then I'll also show you how the tools available in the drafting side on how you can manually create those weld symbols, and a nifty tool that NX provides for automatically creating those weld symbols by simply selecting the welds in the draft if you do not have the PMI capabilities. Now let's hop over to NX where we'll get started. Now, for your information, I am going to be working in NX 1953. However, I do want to let everyone know that NX 1980 is now available. So Siemens has that available on their download site. If you need help getting that set up or getting your licensing figured out for the new version, and you're one of our customers, feel free to contact us, and we can help you get that set up. Now, going into my model here, this is the same model that Brian was using in his structure welding, like I mentioned before. So with the Structure Designer, I'm just going to be taking that model that he created, and I'm going to be doing the welding side with the Weld Assistant tools. Now, for the Weld Assistant tab here, you might need to enable this if you come into NX Modeling and you have this functionality. If you come up here to your ribbon bar and you just right-click, you'll see down here I have Weld Assistant checked. You'll just have to make sure that this is checked in order for this tab to be enabled, so you have access to those tools on your ribbon bar. Now, if I go into the Weld Assistant tab, you can see all the different tools that are associated with the Weld Assistant. We're going to be mainly focusing in on these solid welding commands. We're not going to be touching much of the other commands in here. We're going to be focusing on these, and then the PMI and the information that comes along with those welds being brought into the drafting side. Now we're going to be starting off with the groove weld. Inside this command, we have several different types of groove welds that we can create. I want to go through the list of the different options for those. So there's the square butt, the V groove, the bevel groove, the U groove, J groove, flared V groove, and flared bevel groove. So these are the different types of welds you can create. Now with each of these welds, they have a different cross-section, and that's the differences between them. If I come down here to my cross-section group on this command, and expand that, it'll show me the cross-section that I have selected. So in this case, I have the square butt, and it gives me the associated dimensions with that type of groove weld. So if I were to change this to U groove, the dimensions change accordingly. So I can control those dimensions, and then it labels it so I know which dimension is associated with what. So for instance, I know that R1 is associated with the radius here. A1 is associated with the angle here. S1 is the depth, and then I also have my root opening. Another option with the cross sections for all of these is we have the ability to select whether or not we want it to be a convex contour, a flush contour, or a concave. And with each of those, a new option comes in to control the contour height for concave and convex. If I have it set to flush, obviously it's not there. So that comes along with the cross section and how you can control those different values depending on the type of weld, groove weld that you're creating. Now I'm going to go ahead and set this back to square butt. I want to go ahead and refresh just in case I accidentally clicked anything within there. But now with my groove weld, I have a few other options I want to go through. So you can have your edge prep set to whether or not you want the edges prepped prior or after. So say for instance, you know you're coming in and you're modeling a part for welding, and you actually prep those edges knowing that there's going to be a weld there later on because you know it needs to be set that way. You can set this to prepared so that it automatically knows that or that it knows that these edges have been prepped and doesn't need to do anything to prep them for you for welding. My instance, obviously, I didn't do anything. This model was brought in from a completely different aspect of NX. This was built for the structure designer system. It wasn't built with the intention of being welded, so nothing was prepped on this model whatsoever. So I'm going to leave this as not prepped, but you do have the option to control that if you ever wanted to. You have your prepare edges. So this is how you want, whether or not you want it to be the entire length of an edge, or whether or not you want it to be based off of weld limits or complex edge preparation. So just a brief overview of these. Face sets, this is where you select your faces. So in this instance, I'm just going to be selecting this face here and this face here. We'll come back to that. If I just go ahead and hit show result though, you'll see that it previews the result for that square butt groove weld. Go ahead and undo that. We have also options for weld extent, so you can select the edge sets that you want the weld to go across. So if there's multiple edges the weld's going to be existing through, you can control that. You can control the limits. So say for instance with this groove weld, if I only wanted to exist on the top half of this weld, I can control these 2 points here and have it set to only be this distance of the weld. So that is also an option if you want to control the specific length of a weld along an edge. You can control those manually by dragging the blue control points, or you can specify values in your actual dialog box. We have our skip weld parameters, which we'll get more into skip welds later when we're working with the fillet welds, and I'll talk more about those specifically then, but they are available. And then the weld characteristics that you can add if you would like. So you can add other things such as the setup or arc process if you wanted to. And these settings are all available within the groove weld, and you'll see some similarities between the groove weld and the fillet weld when we get into that. Now, I want to go ahead and confirm my groove weld, and you'll see it creates that weld for me in my model. If I were to come over here to my part navigator, you'll notice it did a promote body for these two bodies here. It promoted them so that it could create the square butt using the two faces of those bodies. And then it also has the groove weld listed here, where it has both bodies selected as well as the square butt weld, all inside of one piece. That's the gist of the groove weld. I just wanted to give you a brief overview of it. Now I'm going to be going over the fillet weld. Now with the fillet weld, you're going to see some similar options in here to what you saw with the groove weld. So for instance, the cross section is going to look really similar. Now for the fillet weld, we don't have these different weld options to choose from, so our cross section isn't going to change that much. But if you wanted to change the contour of your weld, you can. So for convex or concave versus flush, you can control that. And then again, you have the ability to modify that dimension on the contour height, depending on how you want that set. Otherwise, you just have to control the leg length of each of the fillet. So I'm going to go ahead and leave that set to none. And then I'm going to go over here and I'm going to select some faces for my fillet weld. I'm going to select this face and this face for my first set. And then for my second set, I want to select these 3 faces of this gusset here. Now, there's something I want to mention with the fillet weld. This is something that tripped me up when I first started using the Weld Assistant. If I go ahead and hit Show Result here, what's going to happen is it only recognizes that one intersection. And that's based on which face I selected first. So since I selected this face first, it's making an informed decision on which face intersection I want to use for the fillet weld. And that's because of the setting up here that I have set to manual, this extend edges. Now, by default, this is set to manual. But in order for it to recognize and automatically recognize the different intersections between the faces, I need to change that setting to automatic. So if I go ahead and undo, set this to automatic, hit show result, it'll recognize those intersections. So it'll create that fillet weld all around that edge, the intersection between the gusset and the body of the structure. Okay. So that's just something that tripped me up when I first started, so I'd like to mention that. Now, again, you have your access to your limits, similar to how or exactly the same as how with the groove weld, you can control along the edge, how far along that edge you want that fillet to go along. You have your skip weld parameters, which I'll be covering here in a second, and then you're the same welding types. Now I'm going to go ahead and confirm this, and it'll create my fillet weld. Now I want to show you skip welds. So if I come on down here to my cylindrical leg and then my base plate, I'm going to creating a fillet weld, selecting that cylindrical face and the top face of, and the top face of that base plate. Excuse me. Once I have those selected, I want to come down here to skip weld. I want to checkbox create skip welds here. And it gives me some more options available for how I want to define my skip weld. Now, the way you define it is based off of 3 key parameters: the number of welds, the segment length, and the spacing between each weld. And you choose 2 of those, and then you define your skip weld based on those 2. This instance, I'm going to leave mine as number and length. I'm going to leave my segment length as is. And I'm just going to change this to a 5, just to get a couple more welds along that cylindrical face. I'm going to go ahead and confirm that. Oh wait, no. I want to mention one other thing with this one. If I come down here into my settings, and I just check this box right here for assign weld PMI, this is me telling NX I want to assign PMI to this specific weld, and it's going to prompt me when I hit OK. So once I hit OK, it'll create my welds, right? And then it opens up a new window. It opens up the weld symbol window, and it prompts me to create a weld symbol. I'm going to go ahead and click out here in space to reposition my weld symbol. And you can notice that it already has the weld information associated with the weld that I just created populated for this new symbol. And then I have the ability to come in and modify the different characteristics of the weld symbol depending on how I want it set or the standards of my company and how they like to have everything set up. So you have control of that. And this is the typical weld symbol window. So if you wanted to create a weld symbol within drafting, you're going to see something similar to this. Now I'm going to go ahead and set this to standard solid. I think that's all I want to change for this. But I have the ability to come in and change whether or not I want it to be a fork or a box. If I wanted to change it for whatever reason for a fillet, K-groove, this is where you can control that information. So if I wanted to create, when I'm creating a weld from scratch, where I'm not pulling that information in for PMI, I can place that, I can choose that information as I go. But in this instance, it automatically grabs all that for you because I have a specific weld that I am referencing for this weld symbol, and it pulls that information into the weld symbol for me. So it just saves me a lot of work. I'm going to go ahead and just hit close. And you'll notice that weld symbol stays behind, and then I have that PMI left in the 3-dimensional model to reference for my weld symbol. Now, the last thing we're going to look at with the solid welding tools is the plug and slot command. Now, what this command allows us to do is, in instances where we have gaps between our components, such as here, where I have a pin inserted into my base plate, I have this gap here that's left over because the pen isn't quite the same length as the base plate. What I can do is I can select these faces. So I'll select the top face being the bottom face of the base plate, the bottom face being the bottom face of the pen, and then I specify my edge as the circle at the bottom of the base plate, defining where I want the plug to end. So I'll go ahead and hit OK, and it'll fill that gap. You might have noticed within the plug and slot command, I didn't go through them as much with the other ones, but there is another cross-section option, so if you wanted to turn on contour, you can here as well. But that's the plug and slot command. I just like to mention that its availability is there if you ever wanted to look into, or if you ever need it for filling up holes or things like that with the solid welding. Now with that, we're finished with what we're going to cover in terms of the solid welding weld assistant group. So now what we're going to be doing is we're going to be taking a look at the drafting side. Now there's something I do want to mention before we move over to drafting. The PMI that I placed previously exists inside of my trimetric view. And this comes into play when we're adding the base view to pull in that PMI information. But I just want to make a quick note of that before we swap on over. So this PMI exists in the trimetric view, and then we're going to go through some of the settings on how you place that PMI within your base views. So I'll go ahead and swap over to drafting. And it's going to prompt me for a sheet size. I'm just going to leave it as C. And then it prompts me for my base view. Now, what we can do is, I'm going to change the scale down to 1/8. And now, in terms of PMI, so bringing in that fillet weld PMI that I've already created, I want to bring that in when I create this view. If I come down here into settings, under common, I have a PMI group for my PMI settings, and I can choose how I want my PMI inherited. Now there's 3 options in here, well 4. There's none, there's from model view, aligned to drawing view, view only, and aligned to drawing entire part. Now aligned to drawing settings only pull in PMI that exists parallel to the drawing view on a plane that is parallel to the drawing view. So this would only work for, say, a top or bottom view because of the way I had the PMI placed in my 3-dimensional assembly. And then for view only, it makes it so that it only references the PMI that exists in that specific view. So if it was a top view, in this case, since my PMI doesn't exist in that top view, it won't actually bring anything in. But if I were to say entire part, then it would bring in the PMI that I've created into the top view as well. Okay. So since we're going to be doing a trimetric, I'm going to select from model view and hit OK. I'll change this to trimetric. Make sure that's actually changed. Yes, it is. Okay. Didn't know if that reset it. And now when I click to confirm, you'll notice my PMI comes through. And it prompts me to create another view, but we don't need that. So we have our PMI that I already created in terms of that fillet weld. Now, if I wanted to manually create a new weld symbol, I can come up here to my weld symbol command, and I can select that as well. And this is the same layout as the weld symbol PMI that we were working with in the assembly. It looks exactly the same. This is where you can manually put in that information and choose where you want it placed. So I can specify the location I want the weld symbol placed on, and I can specify the terminating object and then put in all the information relative to that specific weld. Now this is a manual way to do it. There also exists a automatic way. So let's go ahead and go into Menu, Insert, Annotation, and then Auto Weld Symbol. Now I'm going to specify my view, and I'm going to select the weld objects that I want to bring in. So I already have a fillet weld here, and I have a groove weld here. Once I have those selected, I can just hit OK and automatically annotate those weld symbols for me, so I don't have to manually type it all in. So it's just a convenient way to create your weld symbols within NX. And that concludes today's webinar. So thank you all for attending. This recording will be placed on our YouTube channel, where you can find all kinds of different information on NX, Solid Edge, or Teamcenter. I do also want to highlight that this structure that we used in this webinar was created by Brian Fisher in his Structure Designer webinar. So if you want to take a look at that and see how he created that model, feel free to take a look at his video on our YouTube channel. We're going to now be opening this up for questions. If you don't have any questions now, or if you want to ask them privately, feel free to email me at matt.radizak@prolim.com, and I'll be happy to get your response as soon as I can to your questions.